The equation of a body exhibiting SHM is x double dot is negative 9x, where x in centimetres is the displacement of the body from a fixed point O. The body starts at O, travelling in the positive direction, and the amplitude of the motion is 5 centimetres. Find an expression of displacement in terms of time. So we have x double dot is equal to negative 9x, and we know x double dot is equal to negative k squared x, and that would tell us that k is equal to 3. So starting at O, travelling in the positive direction, we know that we can write down immediately that that is 5 sine 3t. Now we want to find the velocity of the body at t equals 1 second. So to get velocity, we're going to differentiate. V is going to be 15 cos 3t, and we want V of 1, which is 15 cos 3, and evaluating that is negative 14.85 centimetres per second. We want to find the maximum velocity of the particle, which we know happens when we're at the mean point. I'm just going to talk about this just for a moment. So in this case, we have an amplitude of 5, the mean point is here, and we know that it always accelerates back towards the mean point, which means the acceleration is 0 at O, and so that's where the maximum is. We could also think about that using the v squared is equal to k squared, a squared minus x squared, and if it happens at the middle, that means x is 0. In fact, we can see that it must happen when x is 0 because this part here is subtracted from the a squared. And so V max is equal to just simply Ka, and that's a capital A, isn't it, in the formula? And so we can say that V max is just equal to K, which we established was 3, times the amplitude, which is 5, and so that is going to be 15 centimetres per second. And finally, in this question, we want to find the maximum acceleration of the particle. So we know x double dot is equal to negative 9x, and therefore the maximum acceleration is just going to be 9 times the maximum value of x, which is the amplitude, and so that is 5, giving us 45 centimetres per second squared.